Our lesson today looks at scientific notation. Scientific notation is something that scientists, mathematicians, that we use to express really, really big numbers or really, really small numbers a whole lot easier. So say, for example, you might have a number that looks like this, with a whole lot of zeros in it. It would take us a long time to write out numbers like this. Or, for example, a number that's really small, so something really, really microscopic in size. And the other way, really small to write. Essentially, we can then use this success criteria to express numbers in scientific notation. So our success criteria are these two things. The first number must be a number between 1 and 10. So you can see the first part is a number between 1 and 10. It is then multiplied, so there will always be the multiplication symbol. You can see that pattern goes all the way down. Then using our powers of 10 strategy, so multiplying by tens, hundreds, thousands, dividing by tens, hundreds, and thousands. The last part is an integer with the power of 10. So you can see 10 to the power of 3, 10 to the power of 9, and 10 to the power of negative 2. Let's have a look at that in action. The following questions are expressed in scientific notation. But we want to know what the actual numbers are. So you can see that it has the two parts. It has a number between 1 and 10, so 5.23, and it's multiplied by 10 to the power of 3. 10 to the power of 3 essentially means 10 times 10 times 10, which you might know 10 times 10 is 100 times 10, which is equal to 1,000. Hopefully we know multiplying by 1,000, all we need to do is move the decimal point 3 spots. So to express this number in its actual number, we will just move the decimal point 3 spots. 1, 2, 3, meaning we'd need to add a 0 in here. So the actual number this is showing is 5230, 5,230. This is the number in standard form. 5.23 times 10 to the power of 3 is the number in scientific notation. So it's easy then to convert between standard form and scientific notation. Let's look at the same one down below here. So 6.294 times by 10 to the power of 6. So we could go and write out 10 to the power of 6 as 10 times 10 times 10, etc., etc., etc. But we don't need to do that. We notice that in the first question, 10 to the power of 3, we needed to move the decimal point 3 times. So 10 to the power of 6, we're going to move the decimal point 6 times to make the number bigger. So in this case, I'm going to write this one out. Remember, you can add as many zeros after as you require. Hopefully you have an idea of how many times you're going to move it. So in this case, to increase it, move it 6 times. 1, 2, 3, 4, 5, 6. So the number in standard form is going to be 6,294,000. So that is how we can move numbers from scientific notation to standard form. Now let's work the other way. You can see that we have a couple of rather large numbers. So this first number, 8,293,000,000. Okay? We could easily express this, instead of having it in its standard form, we could express this in scientific notation. Remember, the two criteria are it must be a number on the left-hand side between 1 and 10, and then the power of on the other side. So a number between 1 and 10 on this side, and a power of 10 on the other side. So in this case, the number between 1 and 10, if we put the decimal point, it is definitely the only one that we can have is 8.2 0.93. Remember that we can't change any of the digits in this number, otherwise we'll change the value of the number completely. So if we had to put the decimal point here, it'd be 82.93. It's not a number between 1 and 10. If we put it here, it would have been 0.8293. It's not between 1 and 10. Then we need to work out how many times we moved the decimal point to get it to this spot. So work backwards. The decimal point is currently all the way over here at the end of the number. So we need to move it back 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's times by a power of 10. So 10 to the power of 9. So that is this number here in scientific notation. Same thing with this number. We need to move the decimal point from the end 1, 2, 3, 4 spots back, which give us 5.4, which is a number between 1 and 10, times by 10 to the power of 1, 2, 3, 4. These numbers are also in scientific notation. They have a number between 1 and 10 and a power of 10. But you'll notice that the power is negative. So when the power is negative, it means we are working with a very, very small number. So we need to move the decimal point this time in the negative direction instead of the positive direction. So we're going to move the decimal point left to make the number smaller. So in this case, times by 10 to the power of negative 3 means we're going to move the decimal place 3 times. So this number here, we could put some zeros in front of it. And if we move it 3 times to the left, 1, 2, 3, you'll see that you've made the number a whole lot smaller. So 0.0032, making sure we keep all the digits the same. That is the number in standard form, or the way the number would actually be written. Same thing with this one. Scientific notation, a number between 1 and 10, and a power of 10 on the other side. You can see it is going to be a very, very, very small number because we're going to move the decimal point in a negative direction 7 times. So 7 times to the left. So we could write out the number to start with, and then put some zeros in front of it, which doesn't change the value of that number. Then we're going to move it in the negative direction 7 times. 1, 2, 3, 4, 5, 6, 7. So right in front of that first 0. So we're going to be left with the number of 0.12345 zeros. 1, 2, 3, 4, 5, 6 zeros. Then the rest of the number must stay the same. So be careful, even if there's a 0 in this one, it must stay the same. So 4, 6, 5, 0, 2. So you can see quite a small number, something that we measured quite microscopically. But that is getting a number with a negative power of 10 into its standard form. You'll see these decimal numbers are in standard form. We want to get these into scientific notation. So yet again, scientific notation, number between 1 and 10 times by a power of 10. In this case, the first one, we can move the decimal 1, 2, 3 places to create a number between 1 and 10. We've moved it 3 places, so our power of 10 is going to be negative 3. That's because when we have this number in scientific notation, to get its actual form, we need to move the number backwards 3 places, or in the negative direction, to get it back to its smaller number. Obviously, the other thing to look for is if it's a number that is less than 1, then that's a clue that it's going to have a negative power. So we've moved the decimal point 3 times, moving it 3 times back in the negative direction. Same thing with this one. To create a number between 1 and 10, we only need to move it twice this case. So it becomes 6.039. All those values in their place are really important. Even though there's a 0 there, we don't want to change the value of the number. In this case, our power of 10, we've only moved the decimal point 2 times. Because it's a really small number though, it's to the power of -2. Because if we work back the other way, to get it from scientific notation in standard form, we'd be moving it 2 points backward in the negative direction. So the thing to remember from this video is scientific notation consists of a number between 1 and 10 and an integer power of 10 on either side. So some represent big numbers when the power of 10 is positive, and some represent really small numbers, so numbers less than 1 when the power is negative. The key is to use your powers of 10 strategy, and looking at the power will indicate the number of times you need to move the decimal point to convert from scientific notation to standard form, and vice versa when you are moving from standard form back into scientific notation.